In today's lecture, we're going to put together some of the ideas in this course in order to solve a problem that I'm particularly interested in: natural language parsing. So that's a particular task within natural language processing, which is a part of AI that deals with getting computers to interact with human languages. Now, you should know by this point in this course that computers are particularly good at interpreting programming languages. So one might think that they should be able to interpret human languages, such as English, as well. Well, there's a problem, and the problem is ambiguity. So an English sentence could mean many things and could have many different interpretations. And there aren't always clear guides about which interpretation makes sense in a particular context. So it's the ambiguity in the language that makes processing natural language much more difficult than just interpreting a programming language. Programming languages were designed to be unambiguous, but human languages evolved over time, and so we don't get to design them ourselves. Instead, we try to process what's there in the world. So let's look at an example of ambiguity. Here's a sentence: programs must be written for people to read. This comes from the preface of Structure and Interpretation of Computer Programs, the book. And the idea is you should write programs in such a way that people can read them. We can look at the structure of this sentence by saying that the whole thing is a sentence, and it starts with a noun phrase that's the subject of the sentence, and that's programs, followed by a verb phrase that describes some predicate about programs, that they must be written for people to read. Now, this verb phrase also has internal structure. For people to read is a subordinate clause. It has its own subject, people, and its own verb, read. But it's used to describe how programs must be written. So it's a modifier for this must be written verb. Now, this is not the only interpretation of this sentence. Another interpretation is that programs must be written for people to read, where in this case the subordinate clause modifies the entire sentence, programs must be written. So the meaning of this sentence might be that in order for people to be able to read at all, we need to write programs. Now that's not true, but it is another interpretation of this sequence of words in English. Here's another interpretation: programs must be written for people to read. In this case, to read could be modifying the programs. And if programs are going to be able to read, well, first they must be written for people. Another sentence that's just not true, but is a reasonable interpretation of this sequence of English words. And in each one of these, we've seen a different way of dividing up the words into phrases. And those different alternatives are a case of syntactic ambiguity. So what we're going to try to build today is a system that tells us which structures of the sentence, dividing it up into phrases, are reasonable structural interpretations of a sentence that we type in. So we go from the words themselves to the tree structures. Syntactic ambiguity doesn't just involve how you divide a sentence up into phrases, but also how you determine which syntactic category is being used for each word or phrase. So the word program could either be a noun, meaning a series of coded software instructions, or a verb, meaning to actually write those coded instructions. And likewise, must could be a verb or a noun. Be obliged to is the verb, dampness or mold is the noun. Interpreting this sentence, or resolving its syntactic ambiguity, will involve figuring out whether this word is a noun or a verb. It's a noun in this case. And whether this is a noun or a verb, it's a verb in this case. So we'd like to build a system that does two things: figures out how we break up a whole sentence into phrases that are hierarchically nested into a tree, and what syntactic categories we're using for each phrase and each word.